The Sun is undergoing a magnetic field shift, and 2025 will usher in the peak moment of the 25th solar cycle. The eruption of huge solar flares can trigger unprecedented solar storms. Where does the fate of mankind go from here? Recycled to May 1st, 2024, a seemingly ordinary sunspot appeared on the eastern edge of the Sun. At first, it didn't attract much attention, but as time went by, this sunspot expanded at an alarming rate, eventually reaching 17 times the diameter of the Earth. Then, it released a violent sun-opening flare. Some of the flares were powerful enough to trigger a direct shot towards the Earth. As a result, one of the most dazzling auroras ever appeared on the Earth, and the aurora extended all over the world, those places that have never seen auroras before. NASA pointed out that this is the most powerful geomagnetic storm in 500 years. After the severe solar storm in May, the activity of sunspots not only did not weaken, but continued to release M-class and mild X-class flares, which kept space weather experts on high vigilance at all times. On October 3rd, the sunspot released a huge flare of X 9.0 level, which became the strongest in 7 years. A powerful geomagnetic storm hit the Earth, and the bright aurora lit up those areas of the sky where aurora shouldn't have appeared, and also disrupted radio communication in parts of the world. There are indications that the maximum period of solar activity is approaching, and this time point points to July 2025. Now, NASA has officially confirmed that the Sun's magnetic field has turned over, and the maximum period of solar activity has arrived. So how will the maximum solar activity affect our planet in the next few months? This time of intensifying solar activity? How long will it last? The most important thing is whether it will cause widespread power outages. The Sun looks like a bright and constant ball of light, but in fact it is not stable. About every 11 years, the Sun undergoes a dramatic, exciting transformation, which is the cycle of the Sun. This cycle will influence the discovery of the Earth's solar cycle in many ways, dating back to the late 1970s. At that time, astronomers noticed something strange when observing sunspots. The appearance of sunspots is not irregular, and their number will increase or decrease over time. Observations show that the number of sunspots will increase or decrease every 11 years or so. This cycle was later named Solar Activity Cycle by scientists. Since then, astronomers have begun to pay close attention to this phenomenon. For a long time, they mainly observed the behavior of sunspots to record the activity of the Sun. With the continuous progress of technology, astronomers have found that there are two other changes in the solar activity cycle. One is the reversal of the solar magnetic field. The Sun is a huge charged gas sphere, that is, a plasma sphere, and its magnetic field is constantly changing. Astronomers have found that in each solar activity cycle, the solar magnetic field will undergo a complete magnetic flip. That is, the North Pole becomes the South Pole, and the South Pole becomes the North Pole. Magnetic field flips usually occur near solar maximums, marking the end of a cycle. The second is the whole of the Sun. Solar activity includes solar wind flares and coronal mass ejections. These activities peak during the solar maximum and reach a minimum during the solar minimum. Based on these findings, today's solar cycle requires a comprehensive observation of acute solar activity reversals and sunspot numbers. Since the solar cycle was first discovered, astronomers have tracked and numbered each cycle. We are now in the 25th solar cycle, and each of the previous 24 cycles has had its own unique characteristics. Though most follow the expected pattern of increasing sunspots to a maximum and then decreasing to a minimum, two mysterious periods stand out historically. The first inexplicable period is the Maunder minimum, occurring between 1645 and 1715, a time of very low solar activity. In these 7 decades, sunspots all but vanished. Astronomers observed only about 50 sunspots throughout the entire period, while normally thousands would be expected. This extended minimum coincided with the Little Ice Age. During this time, parts of the world experienced below average temperatures, and rarely freezing rivers like the Thames in London froze. Europe suffered through harsh winters. The second period is the Dalton minimum, approximately between 1790 and 1830. Although not as extreme as the Maunder minimum, this period also experienced below average solar activity. The Dalton minimum, similar to the Maunder minimum, aligned with globally cooler periods. This time also saw significant volcanic events like the 1815 Mount Tambora eruption, leading to global cooling and what is known as the Year Without a Summer in 1816. Europe and North America experienced widespread crop failures and food shortages. The 24th solar cycle, which began in 2008, was particularly weak. Sunspot numbers and solar activity were far below average, making it one of the least active cycles in over a century. Scientists were surprised by its low intensity, noting that solar flares and coronal mass ejections were much less frequent than expected. This led to questions about what could cause changes in solar activity. Could phenomena like the Maunder minimum reoccur in the future? The current solar cycle began in December 2019, and predictions had suggested it would be weaker than the previous cycle. Yet reality has defied expectations. The 25th solar cycle has far exceeded everyone's predictions. In August 2024, the daily average number of sunspots reached 299, which is twice the expected number, a level unseen in over 2 decades. The current solar cycle also has an interesting twist. Its peak arrived earlier than scientists anticipated. This cycle began in December 2019, with an initial prediction that it would peak in July 2025 with an estimated 115 sunspots. However, on October 15, 2024, NASA confirmed that the solar maximum had officially begun, although NASA's statement does not imply that this is the highest level of solar activity. Once the sun enters the solar maximum, scientists need to track its activity for months or even years to determine the true peak. Only after observing a persistent decline in solar activity can a conclusion be made. Clear judgment. It is worth noting that solar activity has obviously intensified in the past 2 years, and the frequent occurrence of sunspots is the symbol of this activity stage. Scientists expect it to last for about a year, in the phase of the maximum activity cycle, before the sun gradually slides towards a more stable period known as the solar minimum. This means that the next few months of 2025 will be crucial. We may usher in severe geomagnetic storms and see magnificent auroras. Looking back on history, there are many intense solar storms that have had a lasting impact on the Earth. The event at Carrington on September the 1st and 2nd, 1859, is the most famous and intense solar storm ever recorded. At that time, British astronomer Richard Carrington caught a huge solar flare. Just a few hours later, the coronal projectile hit the Earth violently, resulting in it. Intense geomagnetic storms have disrupted geomorphic systems across Europe and North America, with some telegraph operators getting shocked. Others noticed their machines could still function without batteries, due to currents from the geomagnetic storm. The auroras reached as far as the Caribbean. The brightness of Sean's night sky can even make people read newspapers outdoors. Gold diggers in the Rocky Mountains thought the sun was rising, and the telegraph line between Carrington and Portland in the United States, 2 operators realized 2 hours of radio communication using only the current generated by the aurora. They also said that this communication method is clearer than using batteries. In May of 1921, the infamous New York Railroad storm hit the planet. This is the strongest geomagnetic feature of the last century. Although there was no satellite system at that time, it still caused serious damage to the Earth's power infrastructure. The storm caused a fire at a train station in Brewster, New York, and also disrupted railroad signaling systems in the northeastern United States. In August 1972, intense solar winds hit the Earth during the Apollo 16 and 17 missions to the Moon. This solar activity is extremely intense, and if astronauts were in space at that time, they would have been exposed to fatal radiation. At the same time, heightened magnetic field activity sparked sensor alarms in mines and an unexplained explosion near Vietnam's coast. In March 1989, a strong geomagnetic storm disrupted Quebec's power network, leaving 6 million without electricity for 9 hours. The outage caused widespread voltage fluctuations and transformer failures in North America. This event demonstrated the power grid's susceptibility to solar activity, leading to enhanced safeguards in the global energy infrastructure. Early in 2022, solar flares triggered geomagnetic disturbances. 40 newly launched satellites were lost. Nowadays, our society is highly dependent on satellites in various technologies, and these coefficients need a stable geomagnetic environment to operate normally. This dependency makes us more vulnerable to major solar activity. Once satellite systems are compromised, it can cause trillions of economic losses, posing huge risks to people who rely on these systems. The most worrying thing is the blackout caused by the eruption of solar flare. The electrons brought by solar storms will charge the Earth's atmosphere, and then the current will flood into the global power grid, destroying power facilities around the world, exploding high-voltage wires, and damaging giant transformers. Due to the long manufacturing cycle of giant transformers, difficult transportation, and scarce spare parts, it is difficult to recover from global blackouts in a short period of time. Once electricity is destroyed, human society will face extinction. After several hours of electricity in the global whole, the circuit may appear capacitance phenomenon, causing a fire. If a spark appears near a natural gas pipeline, it will also cause a big explosion. After that, all fires will also become extremely difficult, because many water supply systems rely on electric pumps to keep residents drinking water, which will also become the primary problem, and food will be in short supply, and the whole city will fall into chaos. The Japanese movie Survival Family describes the impact of the blackout caused by the solar magnetic rod on the city. One of the most impressive plots is that a rich man goes to a convenience store with a famous watch and car to exchange food, but is blasted out by his boss. This means that by then, the famous watch and bag may not even be exchanged for a piece of bread. Perhaps the most terrible disaster happens in nuclear power plants. The fuel of nuclear reactors needs to be kept in cold water, otherwise it will melt and release deadly radiation. Once the power goes out, the nuclear fuel rods lose cold water, and the cooling temperature will rise sharply, which may eventually lead to an explosion, which may be much more severe than the Chernobyl incident.